So since such a problem was there, our primary assumption of that the pyramidal tract is controlling the alpha motor neuron. It's sending impulses, and that impulse is going on to the periphery is challenged. So now we are looking at what is alternate model. And we say that there are going to be 3 levels. So we had discussed about level A, or the external load when it is applied. That's the first part. Second one is level B, which is the spinal cord. So as last class we had done with the spinal cord, how it is being controlled, right? How the spinal cord controls the muscle. So what we are going to do now is we are going to slightly refresh the idea, and I want you to please speak or give the answer so that we have a precise understanding. Then we will move on to the next part, which is how the central command is going to come. Okay, right. So I would now, what I would want is I want you to identify these structures. So I'll be pointing an arrow, and I want you to let me know what are these structures. Okay, right. So can you tell me what is the structure?
Sir, it is for all or only for students?
Let it be for the others, Subbu. Okay, right. So I want the first year as well as the second years to tell me what is the structure which is there. Just if anyone can open your mic and speak, it should be fine, right? Even if you make a mistake, it's okay. Don't worry about it. We'll correct it just to recall, because that idea is required.
For muscle spindle.
Sir.
Yeah. Yeah. A second person also can answer.
Sir, this is a
Muscle spindle, right? Okay, right.
Yes,
so
sir.
what is this structure in red? Yeah, a bit fast if you can answer. We can be moving towards today's. What is this structure?
The muscle.
The muscle, right? Now in muscle spindle, you have a central portion and this portion, right? So can you tell me what's the difference between the central portion and this portion? What is this portion? Yeah.
Sir, that peripheral portion is Golgi tendon, and the central one is muscle fiber, like alpha or beta.
Okay, no, it's it's not that. This is your tendon, and all your Golgi tendon organ is going to be here. We are not worried about it. This is the muscle spindle, and this is the terminal portion of the muscle spindle. It has muscle fibers which are called as intrafusal fibers. Okay, right? And the this central portion, right, has your the sensory part of it, which can tell how much length it is. Okay, right? So this neuron, 1A neuron, ideally will be starting from this portion, right? And what is this neuron called as?
Sir, gamma motor neuron.
It's the gamma motor neuron, right? So it supplies the intrafusal muscle fiber. Okay. All right. So it supplies the intrafusal muscle fiber. Now, this is the alpha motor neuron, right? And there is a connection from this 1A, which is the sensory part, which is going through to here. It is connected to alpha motor neuron. Okay, right? Clear? So can you tell me overall together, last class we had seen, together all these things, I'm sorry, together all these things when they are functioning, they are going to convert the muscle into a specific structure. Can you tell me what is that structure it converts the muscle into?
Closed loop control.
Yeah, it's a closed loop control. So the muscle is going to transform into a structure which has very different properties. So what is that structure to which it is going to change?
Sir, elastic structure.
You're right. It's going to become a elastic structure, right? So now how is it going to become an elastic structure? All right. So this is the loop. Can anyone try and explain this? Actually, yeah, right. So can you just explain this whole phenomena?
Yes, sir. So when first gamma will be activated,
Yeah.
once the gamma activate, it will stretch the center like a spindle. It will be
Yeah, it will
stretching the
contract
spindle.
before stretching. It will first contract this
Contract,
portion.
yeah,
Okay.
terminal, and then which will activate 1A sensory
Fiber.
like a fiber, yeah,
Yeah.
which in turn will activate alpha,
Yeah.
yeah, and that will cause the muscle to contract.
Contract. And
Yeah.
once the muscle
And
contracts,
then this the spindle will be like coming back to like how it was, like normal.
yeah, because what happens is this whole muscle becomes shorter. So the spindle also will be pulled together. Okay, right? So it will reduce its length. So it will return back automatically to its original position. Okay. Yeah.
Yeah.
Are
Okay.
you clear with this?
Yes.
Okay, right. So now, because this particular thing is there, what happens is the muscle transforms into a rubber band. Okay, right. So now I'm going to spend some more time onto the rubber band. So what I want you to do is I want you to take the rubber band. Okay, and if anyone can just open your video. Have you got the rubber band? Have anyone got the rubber band? Yeah, can anyone just yeah. Have anyone got the rubber band? If yes, you tell yes, otherwise we can just.
Yes, sir.
Yes, sir.
Okay, yeah, we've been.
Yes, sir.
Okay,
sir.
because if you have got it, it will be very easy for us. So I'll ask Vipin to do that, right? So Vipin sir, can you just show me the rubber band?
Sir, are you able to see?
Yeah, no, can you just show it to the video? Yeah, right.
Actually, I'm not able to see my video.
You're not able to see your video. One second. I can't see your video now. Yeah. Yeah.
No.
Right. So that's the rubber band. Okay, right? So clear. So now point number one, which we made was the muscle is going to act like a elastic structure that is similar to that of a rubber band. Okay, right? So now let's just do something. Vipin sir, I want you to just hold it right without any slack. Yeah, without any slack. Yeah, right, tight. Okay, right. Now, what I want you to do is I want you to pull it out for say 2 centimeter and then leave it. Yeah, and then no, or keep one hand stable and just the other hand will have to move for 1 centimeter and then leave the rubber band. One hand you hold it, yes, right? So what has happened once you take it to a certain position and then you leave it, right? It comes back to its original position. Okay, right? Okay, thank you, Binsa. So now, because of this particular nature, that's what we saw as the model of control, right? So this closed loop control actually brought in and it had converted the muscle into a rubber band. Okay. So now, right, so now what happens is the force we are the force with which it pulls is directly proportional to the length, okay, of the muscle. So greater you pull, greater will be its distance. Okay. So now let's see. Today we tried doing a small experiment in order to see what happens to the tension level in a rubber band. So we used a TheraBand in order to study that. So I'll just show you that. Yeah, right. So this is just basically a weighing machine, but it is digital weighing machine. So if we are going to pull in here, it will show us what is the amount of force with which it's being pulled, right? So what we did was we attached a TheraBand, right, to it, and then we started pulling it. Okay, so you can see here the other end of the TheraBand. All right. So in this first picture, we had kept it at length A, right, which is a shorter length. And then what we did was next we pull the chair to a next level. You can see the drawing line in the floor, right? And then we had still moved it to the longer length. Like this, we moved it, right? And you can see that this is the green TheraBand. Okay, right? So now what I want you to do is the machine actually gave values and the values are available. So I want you to just say write some 3 values for each one of it. You can have it as length 1, length 2, and length 3. And I want you to write down what would be the tension. Okay. You can give any value. And once you do it, I want you to just plot a length tension curve. And I want you to just keep these marks and connect them. Can you just do that? And then I want you to show the paper. I want all of you to try and do this. If you don't understand the question, you can ask me. I can repeat the question, not a problem.
Can you repeat the question?
Yeah, right. So you saw that I had tied a TheraBand to a chair, and we had kept one end of it to that meter, right? And from that, we had pulled it. We had 3 different lengths. First was a shorter length, then was a medium length, then was a longer length, right? So I had pulled it. Now on the meter, right, it tells how much amount of tension will be there in that particular band, okay, right, at that particular length. So what I want you to do is, I want you to keep these 3 lengths as 1, 2, and 3, and then I want you to write what would be the tension which the machine would have measured, right? So I want you to compare 1, 2, and 3, and I want you to plot a graph of it and then show that graph to me, right? So the length will be in the x-axis and the tension will be in the y-axis, and I want you to show to me. This is what we did in the, we have explained in the last class, but still I want you to really draw it. Once you draw, please open your video and then you can just show me the graph. Yeah. Okay. Right. Great. Anyone else? Yeah. That's fine. Okay. Yeah. So I can't see yours, Prestige. Yeah. Okay. Right. So all of you have drawn a graph, right, which starts and goes up. Yeah, Dharmita. Dharmita, you were, can you just show?
Yes, I'm just trying.
Okay, fine. I think this video. Anyone else would like to show? Then we. Okay.
I hope, sir,
So
this is visible to you.
yeah, it's visible. So it's an inverted U shape, right?
Yes, sir.
Okay, right. So you had initially it's less, then it's increasing, and then it'll again reduce, right? That's what you're drawing.
Yes, sir. Yes, sir.
Okay, right. Anyone else? Okay, right. So we had seen 2 different types of graphs. So in order to clarify the confusion as to what type of graph it can be, right? So we also collected the data, and then we plotted the graph. Okay, right. So I can show you the graph now. Is the screen visible?
Yes, sir.
Yes, sir.
Okay, right. So can you see this? I'll tell you what is this 2 graph. These 2 graphs are actually 2 different bands that will come later, but we used 1 TheraBand, okay, right, and then the other TheraBand. Now you can see here, all right. So this is a green TheraBand, And we repeated the same experiment with another TheraBand. So we have two graphs. I'll come to it why I have repeated that. But okay, can you see this? Yeah, right. So this is of the red TheraBand and this is of the green TheraBand. Okay, right? So you can see that Dharmita, you had actually drawn a graph which is an inverted U, but when we had increased the length, actually we got a graph which is like this. Okay. Okay, right. So what it precisely tells is, as you are increasing the length of it over here, the tension keeps increasing. Okay, right. So yeah, right. So as you increase the length, the tension gets increasing, and that's why we are having a graph which is like this. Okay, right. So now we are going to go back, and the formula, if you have to put this in a formula, all right, can you tell me what is the formula you will put it?
Excuse me, sir. Can I?
Yeah, please.
Sir, usually when we see the pictures in the textbooks and all, you'll have a very smooth curve. And
Yeah.
here, so you have done it like.
Okay, right. So there was a slight reason for that. The reason was actually basically the reason was we did not keep this. All these are not equidistance. Actually, 2 points. Yeah, I'll just show you the data. 1 second. All right. Okay. Can you see the video?
Yes, sir.
Yeah. Can you see this?
Yes, sir.
All right. So the distances we had actually kept was not equidistant. It was 60, 80, then 120, then 140, then 180, then 200. So there was a different gaps, 20 and 40. Okay, right.
Was there any particular reason for that, sir?
Yeah.
Was there any? Sir,
Yeah,
was
there was a small reason for it, but actually it could have been done either ways, not a problem, but we had kept it like this. Okay, right? And here you see this K0, right? That's the graph of the red TheraBand. Okay, you can see the values 0.590, 1.270, 1.435, and it went and increased. Right, and the green band, we had actually increased its distance by making it into double, right? And you can see here the values of it, okay, right, as they're increasing. And so these values have been plotted on the graph. Okay.
Okay.
Yeah, right. Right. So are you all clear as to when we are going to have an elastic structure, how the curve will be? Right.
Yes, sir.
Yeah. Now, number 2, right? So if you have to write an equation of the relation between the force which is being generated and the length of the muscle or the length of any elastic structure, all right? So what will be the kind of relation it will be? F will be equal to or proportional to?
Length.
Yes, so F is directly proportional to the tension of the band or muscle.
F is the tension, so it's directly proportional to the
Length.
yeah,
Length of the band. Stretch.
length of the band. All right. So if I have to just say write an equation, this I can write it as F is equal to, or it's proportional to, let's have X, right? So as you increase it, then what happens? The resistance increases. Okay, right? So now we would try and test it on ourselves. How this equation turns out to. So what I want you to do is, I want you all to put your hand in a flexed position. 1 second. I want you to hold your hand like this. Can you see me? Right. With the shoulder down and the elbow bent. Okay. Like this. Okay. Right. Okay. Can someone just open the video so that I can see you? Yeah. Right. Okay. Right. Now, what I want you to do is, I want you to maintain this particular. Yeah. So now what I want you to do is, I want you to maintain this particular position, and I want you to tell your brain that you will have to maintain in this position. Okay. Now, what I want you to do is, I want you to, with the other hand, I want you to push it a little bit and then leave it. So your goal is to just maintain this length. Now you're going to just push it and leave it. Okay, right? Yeah, I saw that. Now what I want you to do is, I want you to now press and keep going. But the intention should be to come back to that original position. That's the position you're going to maintain. See here, I left it and it came, right? So now I want you to just press and go, right? And I want you to feel how much resistance you're feeling in different positions, right? This versus this. What do you feel? Can you just share your how much resistance you felt?
More the elbow extension, more the force, sir.
Okay, right. So more you're trying to push it, right? You get more the force, right? So what's so if you are going to try and push it more and more, you will feel more and more force, right? When you're trying to maintain this position, but still when you're applying a resistance to the other one, right? So this is what they measured, and they said that the equation is F is equal to F is proportional to X. Okay, right? So now what we have seen is, in reality, when we are trying to move, right, something from its original position, right, it acts like, as you increase the push, it regains back and it has more amount of resistance it gives. Okay, right, number one. Then we had also seen that in a rubber band or a TheraBand, when you're trying to pull it, right, as you pull more and more, the resistance keeps increasing and it keeps going on. Okay, right? So the reason for why it acts like that is, we saw that in the spinal cord, you had the gamma motor neuron. If the gamma motor neuron is set at a particular level, then whenever you are going to try and pull the muscle out, right, the muscle spindle will be stretched. That will give closed loop feedback control, and it will bring it back to the original position. Okay, right? Yeah. So this is how the muscle is being controlled. Are you clear with this?
Yes, sir.
Yeah, right. So now I'll ask you a question. Say, for example, a person is maintaining a standing posture. Okay, right? And what you're doing is, you're going to push the person from behind, right? A little bit, right? Clear? What do you think will be the muscle activity? Now compare this with, you're going to push him a lot more, right? And then what will happen to the muscle activity?
When we push more,
Ankle strategy and hip strategy and stepping strategy like that.
No, we are not talking about the strategy. We are telling that you maintain this position, And what we are doing is only the ankle strategy, but we are giving a little amount of push and more amount of push. So when you give more amount of push, what will happen to the calf muscle activity?
The activity will be more when we push more. The muscle will try to maintain the posture more.
Okay, right. So it will be more activity will be there. That's basically it is just it will be pulling back to you, right? So when you maintain any posture, this is how the brain is controlling the movement. Are you clear with this?
Yes, sir.
Yeah. All right. Now, what we will do is we will move on and see, right, what happens when we start moving, when we have to move from one position to the other position. So, can you just tell me? I think last class we had, right? So now, what we'll do is we are going to use the two therabands. They do have two different amount of tension levels, right? So we will see what happens when we suspend a particular weight on one theraband and then use the other theraband. Okay, I hope the screen is visible. Yeah.
Yes, sir.
So this is a video. So you can see that I have kept a scale, right, at a particular length, right? Now I'm going to just suspend it. Right. So I'm taking it to that particular length and I have just removed my hand. Okay. All right. Okay. Now I'm using the other theraband. I've removed my hand. Okay, right. So I'll repeat the video once more. What this video shows is I'm going to leave an object of same weight on two therabands. Okay, right? Okay. So now what we see is we have two therabands, and we all know that the theraband 1, that is the red theraband, and we suspended, right? The object was in a certain position. Okay, right? Now, when I changed the theraband, right, and suspended the same object, it was in a different position. Okay, right? Can you just tell me why in the two therabands the same object was in two different positions?
Sir, because of the resistance which is provided by theraband, maybe green color theraband is more resistive than red one.
Okay, right. So it is more resistive, so it didn't allow, right? So now we will go back to the previous right. So, right. So you see that the amount of resistance which each offers is not the same thing. Okay, right. So now let's introduce a factor. All right. One second. All right. So let's assume that the red theraband here is this one. Okay, right. So it gives a different value. So I'll introduce another part to it. Let's call it as K1. Okay, right. And I'll just keep this. For the sake, I'll keep it as color. Yeah, right. So the equation for this is F is equal to K1x, and the equation for the second one, right, is F is equal to K2x. Sorry, just okay, right. So can you see this? F is equal to K1x, right? So now what we have done here as an experiment is we converted one TheraBand, which offered a certain amount of resistance, to another TheraBand with a certain amount of resistance, right? So we replaced this with this, and you can see that the curve will just move, and along with that, what happens is the object will also move. Are everyone clear with this?
Yes, sir.
Others?
Yes,
Yes,
sir.
sir.
Yes, sir.
So what basically does the brain do here? What is the role of the brain in this particular part is, right? So when your muscle is going to change in its length, what is going to happen is this is the degrees, right? The joint degrees, 10, 20, 30, and 40 degrees, right? So what happens is the central command which the brain is giving, we'll call that as lambda. Okay, right? Yeah. So we have here lambda 1, lambda 2, right? So what happens basically is the brain shifts the lambda, right? Or it is called as a threshold length of muscle change. We'll discuss about what is a threshold length of muscle change in a next class. But for now, right, what happens is the brain just changes the K, or the stiffness of the spring. Okay, right? So now how does it achieve it, right? So so you can see here, F is equal to K into del X, right? So this is the resting length of a muscle. If you're going to pull it, right, it's going to return back to its original position, right? That's one way. And so our posture is controlled by this particular mechanism. So whenever you're maintaining a posture, it can actually be in whenever you're trying to push it, there will be increase in activity. When you don't push it, it will be in a particular length. Okay, right? When you're trying to move, what happens is you can see that this spring and this spring is different. This is a more stiffer spring, or a TheraBand with more resistance, right? So what brain does is it changes the stiffness, which is the K is called a stiffness, or the spring constant, right? So that is being changed. It's replacing it. Okay. Right. So, all right. I'll come to this. 1 second. Sorry, just. Okay, right? So if you see here, we have spoken about the spinal control, and we saw this particular loop. Now, the only thing you need to understand is the central command, which is coming from above. It's called as lambda, and it directly comes on to the gamma motor neuron. And what it gives is, it gives a continuous output, right? It's called as a tonic output, tonic continuous output, or it's called as a tonic stretch reflex, right? So now this tonic stretch reflex, when you're maintaining a posture, there will be a amount of contraction, and then when you're going to shift it to another position, what the brain does is it just changes the central command to a different level. And because it changes it to a different level, the gamma motor neuron, which was sensitive at one particular length, now becomes sensitive to another particular length. And so it starts pulling the muscle to another length, and it goes on to the other length. So in this way, movement comes. Okay. Are you clear with this?
So one doubt.
Yeah.
Sir, so like when like brain commands, so the muscle fiber changes from like it's like changing from red to green, or it's like changing it just the resistance level, like as the length changes in the within the green band,
No,
like that.
it's not within the green. It changes from red to green or green to red.
Okay.
Right? So
Okay.
F is directly proportional to X. So that's the property of the spinal muscle. What I mean by spinal muscle is a muscle which is purely under the control of a spinal cord. Okay, right? Clear? All right.
So this is happening to the same muscle, like.
Yeah, it is happening to the same muscle.
Okay.
Right? So now when we are changing, the brain changes the stiffness. It doesn't change the X, it changes the K.
Yeah, got it. Yeah.
Okay, right. So now let us look into the combined influence of these ones, right? So I'll introduce certain terms. The first term is going to be lambda. You know what's a lambda? It's the central command which is given by the brain. The second one is called as IC. It is called as invariant characteristic. What we mean by invariant characteristic is, say for example, you take a red color TheraBand, then it has a certain characteristic. That is, it has a certain relation of F to X, right? So it is K1, right? So there is a spring constant and that, or stiffness, right, to it. So that cannot be changed, okay, right? So whenever you use the red TheraBand, you are always going to face the same level of resistance. So it is called as an invariant characteristics. Variant means it varies. Invariant means it does not vary. Okay, right? Clear? So now that's from the spinal level. Your spinal control is making your muscle to have a certain level of elasticity. So it's called as an invariant characteristic. Now, what happens is whenever we move, we either may be moving our own limb or we may be moving a external load. Okay, right? So all these three are going to come together and they are going to interact together. Now, what happens is you saw in this particular experiment, right, that once the object was suspended, it took its own position. Okay, right? Clear? So that position is called as a equilibrium point. Okay, right? Now, what's the equilibrium point? Now you have this curve, right? This is what is the curve we have already seen. Okay, right? Clear? Now, when the load is going to come, it is going to maintain the length of this particular TheraBand at one particular thing, right? So together with the load, the TheraBand will now assume a different length. So it is going to assume a particular length, right? So this particular point, right, is called as the equilibrium point. Okay, right? It's the point where all the three come into a unified whole and they the muscle is said to have reached an equilibrium point. Okay. Do you understand this?
So the set by the lambda can be changed after these interactions, right, sir?
Yeah, the lambda can be changed after this interaction. This
Right.
is it is maintaining at a particular point, right? So
Okay.
the brain, when it wants to change, it changes the lambda and the
Okay.
curve can shift. As we saw
Okay.
in the experiment, the curve
Okay.
basically shifts into one direction. And
Okay.
so the position at which the object is will come into a new position. Okay.
Okay. Okay. Can we think in such a term, like the brain decides the lambda and it finalizes something. However, the output can be changed because of these combinations, which may not be exactly controlled by the brain.
Yes,
Yes.
exactly. Right?
Okay.
The brain may not be exactly controlling that.
Okay, sir.
So that brings us to the end of the equilibrium point model. All right. So I hope when you look into all the three levels, right, they all have a particular role to play on, and then finally it comes to a equilibrium point. Okay, so are you clear with this? Any questions or any doubts? Any more opinions or suggestions or points? If you can also add, it should be fine.
So basically, this EP model then gives us the answer of the big question, like how brain can go and find each and every minute details. It is not it. We can think in certain way, like it gives an overall some gross idea, but however, the exact execution depends of not only depends upon the lambda, but also with all these as well as IC and as well as the external node. That
Yeah,
is how.
now that is something which we will try to discuss in the next class about
Okay, sir.
the exactness of it, because our problem was how to make it come to that exact point, right?
Okay,
That
sir.
was the
Okay.
question.
Okay.
So with this basic understanding of what is the equilibrium point and how the muscle is acting, we will just try to fit it into different situations. Okay, right? So how
Yes.
a muscle is being controlled, how a joint is controlled, how multi-joint control comes.
Yes, sir. Yeah.
We'll just slowly go one after the other.
Okay, sir. Okay.
So if anyone have any doubts in this particular thing, you can just let me know. Okay, right? So otherwise, if you're okay with that, we can just move on. We will be meeting, I think, in the next month, the first week, we'll be meeting again for this particular equilibrium point model. Of course, the other things like behavior change and other our direct workshops will always be continuing as previously planned. We are ready to plan the first workshop, so we'll let you know about it. Thank you all for listening. I'll
Thank you,
now
sir.
stop recording.
Thank you, sir.
Thank you, sir.
Thank you, sir.